In this lesson, we will learn to assign oxidation numbers to free elements or elements in a compound or ion. Oxidations are the number of charges an atom would have in a molecule if the electrons were transferred completely. Remember that in ionic compounds, electrons are transferred completely, but in molecular compounds, they are shared. The reason we look at oxidation numbers is to be able to understand how reactions are happening and to be able to predict products of other reactions. This list summarizes the rules we will use to assign oxidation numbers to every atom. We will go through the rules and give examples for each. These rules are numbered in the order in which you should apply them to determining the oxidation numbers of multiple elements. The oxidation number of an atom in a free element is 0. Note that these are all neutral species, and we know they are neutral because there is no charge explicitly shown. Remember that any species that has a charge, whether it be positive or negative, must show that charge on the particle. This rule applies whether we're dealing with atomic or molecular elements. So the oxidation number of sodium is 0, as is the oxidation number of hydrogen in H2 or oxygen in O2. The second rule is the oxidation number of a monatomic ion equals its charge. We see some examples of monatomic ions on the left, like sodium plus, which has an oxidation number of +1, magnesium 2+, which has an oxidation number of +2, sulfur 2- has an oxidation number of -2, and F-, which has an oxidation number of -1. Ionic compounds contain ions, so monatomic ions are present and have a charge within that compound. When we look at NaCl, we know that this is an ionic compound because we have a metal and a nonmetal. And we can determine that that ionic compound is composed of Na+ and Cl-. Therefore, the oxidation number of Na+ will be +1, and the oxidation number of Cl- will be -1. Magnesium chloride, also composed of a metal and a nonmetal, is also an ionic compound. Magnesium has a charge of 2+, chlorine still has a charge of -1, and our oxidation numbers are +2 and -1 respectively. Remember that just because the charge isn't explicitly shown on the ion doesn't mean that there can't be charged particles within the compound. The oxidation number of oxygen in a compound is usually -2. In the case of an exception, you would be given the oxidation number of oxygen in that particular compound. The oxidation number of H in a compound is usually +1. Like with oxygen, there are some exceptions. If there are exceptions, you will be told the oxidation number of hydrogen for that particular compound. The oxidation number of fluorine in a compound is -1. For other halogens, such as chlorine, bromine, and iodine, they are typically -1 in binary compounds, but will vary in other compounds. And we will see how we determine the oxidation number in those other cases. Note that a binary compound is a compound that contains 2 elements. However, it can contain more than 2 atoms. The sum of the oxidation numbers in a neutral compound equals 0. Let's look at an example with NaCl. We know that NaCl is an ionic compound because it's a metal and a nonmetal. So we know the charges on the ions that compose the NaCl. So we know we have a +1 for sodium and a -1 for chlorine. +1 plus a -1 is equal to 0. For water, Our rule for hydrogen is that the oxidation number is +1, and for oxygen, the oxidation number is -2. I take 2 times +1 plus a -2 gives me 0. Note that because there are 2 hydrogens, I have to multiply the oxidation number of each hydrogen by 2. When we report oxidation numbers, it's always per atom of a particular element. The sum of oxidation numbers in a polyatomic ion equals the charge. Looking at OH-, which is the hydroxide ion, we have oxygen with a -2 and hydrogen with a +1 oxidation number. -2 plus a +1 equals -1. For NO3-, which is known as the nitrate ion, we don't actually know the oxidation number for nitrogen because there's no rule that applies for nitrogen, so we label it X temporarily. We know that oxygen has an oxidation number of -2, and now we can set up an expression to solve for the value of X. X plus 3 times -2 will be equal to -1. So X minus 6 equals -1, and X equals 5. Therefore, the oxidation number of nitrogen will be +5.